having to do a funeral detail for their family, so that means somebody passed away. So, and it's pretty good when students communicate with the instructor. Maybe I should tell students that the first week of class. All right. So anyway, statistical reasoning, and let's see, slide 12. And yeah, this, let me go back here. I'm going to go back here and slideshow and from current slide. Now, as I told you before, these are SAT questions, and I'll tell you what the questions will ask you. The bar chart, they will ask you, they'll just put a bar chart like this on the test, and I will too. Oh, let me turn my camera off. And you're welcome to turn your cameras on, but that's okay because I had mine on. They will just put this on the test, and then they'll say how many are in the class or what is in or something like that. And you just go through and you add up in, and that's it. That's the question. This, I think, goes with this, but here there's a frequency distribution. Here, the test question would be, what is the relative frequency? And you would go over here and you would say, 4 over 25, 7 over 25. Now, remember, 90% of the time, they will want a decimal, and usually they want it to the hundredth. So if you wasn't here Monday, make sure you write that down. That usually they want it in decimal form, and usually they want it to the hundredth, and that's the relative frequency. Here, the first thing you check is make sure it equals 100%. If it doesn't equal 100%, then the question will ask something to the effect, is this a valid pie chart or something? And it'll ask you that, or something to the effect, is this pie chart usable? Is something wrong with this pie chart? And then they'll give you a choice of answers or whatever, or they'll just open answer and say, what is wrong with this pie chart? And usually, if it says that, that means it's over 100% or under 100%. So those are the 3 test questions that you would see on a standardized test or my test, because I will test you at least on these 2 right here, bar chart and pie chart. And relative frequency is on my test also. Excuse me. Now, I'm going to switch over down here to the histogram and show you the difference between a histogram. There is no difference between a histogram and a pie chart. The only difference is the boxes touch. Now, I don't know who came up with a histogram idea, but to me, I think it's useless. I mean, if you're OCD and you like for boxes to touch, then you like histograms. If you're OCD and not like boxes to touch, you like bar charts. To me, that's the only difference between the 2. Now, if you connect the dots, if you put a dot here and a dot here and a dot there and a dot here and a dot here, then you've got a line chart. These are used a good bit in business and marketing. It's easier to see, the difference or the rate of change with a line graph or a line chart versus a histogram or bar chart. This is my preference. I would rather use this in a math class than anything. So on the previous slide, there's a line chart right there. And a histogram is a bar graph for quantitative data. The bars have a natural order and the bar widths have a specific meaning. They really reached to do a definition for a histogram. Because if you go back, I was going to see if they had a definition for a bar chart, but A bar chart shows each category with a bar whose length correspond to its frequency or relative frequency. I mean, they really reaching to do a definition for histogram that's not equal to a bar chart. I mean, I've already said it once. I really think somebody just made up something to sound more sophisticated than a bar chart. And a line chart and time series. I'm not gonna test you on time series. I'm just not. So you don't have to worry about time series. There is another example of a, and you ought to write that one down and use it for a test question, because I would ask you the class width. I would ask you the class boundaries. I would ask you the midpoints. I would ask you what N is, what's the total, and I would ask you what the relative frequency is. So with that question right there, you could have 4 or 5 test questions. So let's take a second and do that just as a refresher for what we've been over so far. So I'm gonna write it down, and then we'll go to my document cam, age, and actresses. I'm gonna just put F, because I really don't care about what it is. So 20 to 29, 30 to 39, excuse me. That's why I drink vodka, to make, cut everything. That's alcohol does that. To 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89. And my 32, 34, 14, 2, 6, 1, and 1. All right, so I want everybody to take a minute. I'm going to go to my handy dandy. There we go. I want everybody to take a minute. I'm going to time you. Well, 2 minutes. Do 2 minutes worth of work on this problem, and you should be able to, the first thing you're going to get is you're going to get the N. You got to get N first. And then after that, the class width, the relative frequency, the class width, class boundaries, and the midpoints. So go ahead and find those, and I'm going to time you at 2 minutes. And after 2 minutes, we'll get started on it together, and you can fill in the blanks. Oops, sorry. And if you can't do it, we'll just chalk it up as what? Failure? Yeah. I'm looking to see if anybody else came in today. Looks like we got 15 in the class. Miss Stewart, how are you this morning?
I'm good.
Well, I'm glad. You're not drinking any adult beverages there, are you?
Nope, just lemonade. Nothing else.
Okay. Oh, yeah, sure. Probably hard lemonade. Probably Mike's hard lemonade. You probably got you on your 3rd bottle. Yeah, I only see. Let's see. I don't think anybody else has showed up that wasn't here Monday. These hybrids have got me all mixed up. See, I'm teaching 3 hybrids and 3 synced classes, and I'm getting mixed up sometimes. So I apologize for doing that to y'all at the beginning of class. Okay, we're getting close to 2 minutes. Hopefully you're through with a lot of the work, but if you're not, we can fill out the drop slip after class if you want to. All right, so here we go. First thing I'm going to do is I'm going to add everything up. Well, that's going to be 66? 66 and 14 is 80. And then that's 88, 89, and 90. What'd y'all get? Did y'all get 90?
Yes, sir.
Yep.
Yes, sir.
Isn't it a miracle that I did that without a calculator? And no, you should not need a calculator to add those up. So don't say a word. I don't want them to know, but you don't need a calculator to add those up. All right, so n is equal to 90. I'm going to go ahead and do my relative frequency. Now, you do need a calculator. Unless you're Rain Man, you do need a calculator to do these decimals. But you don't need a calculator to do the fractions. So I'm going to do the fractions. And, of course, you can fill in the decimals however you want to. So relative frequency is going to be 32 over 90, 34 over 90.
You have a work email.
14 over 90, 2 over 90, 6 over 90, 1 over 90, and 1 over 90. And those corresponding decimals would be wherever they fall. And make sure you read the directions, because you want decimals 90% of the time, but you got to read the directions on what? On rounding. Make sure you read the directions. Now, the class width. Now, why do I get the class width first? Because the class width helps you calculate the class boundary and the midpoints without doing extra work. So the class width, I'm going to go over here and I'm going to highlight two numbers. And I'm going to highlight one orange and one yellow, and I always go with the first two. So 30 and 20. Now, Miss Stewart, she likes to be a rebel, okay? So she might go down here and pick 89 minus 79. I don't care as long as they're vertical and they're corresponding with each other, meaning one follows the other. Okay, I don't care which one you pick. You can't pick 89 and 49. You can't do that because they're not corresponding. So I go over here and I go 30 minus 20 is equal to 10. And 10 is our class width. Now, the reason I'm going through this is because I've had a couple of emails from 103 and 120 students, because we're going in the same direction with this. In Unit 1 and Unit 2, Probability and Statistics. I've got a couple of emails from, I would say 2 out of each of my classes. 2 out of 103, 2 out of 120. All my 120s, that's 6. That's about 8 students. And most of the time, these are from students that have never had probability and statistics before. Several students have told me that they learned how to do this in high school probability and statistics. That's fine. But 2 or 3 students didn't have probability and statistics in high school, and they need to know how to do it. So, and I realize there's some that invented probability and statistics. But we do have a couple in each class that did not. So we're going to teach. I'm going to keep teaching until everybody gets it, or at least mostly everybody. All right, class boundary. What? These are whole numbers, right? Yeah, so I'm going to go to the 10th, which means I'm going to use 0.5. Since these are whole numbers, I'm going to use 0.5. If they were to the 10th, then I would use 0.95. I'd go to the hundredth. If these were to the hundredths, then I would go to the thousandths, which would be 0.995. Now, you could use any number, but that's what usually people use, those 0.995s, 0.95, 0.9995, 0.999995. That's what people use after, you start getting, but you don't have to worry about that because most of the time they're either going to be whole or to the 10th or to the 100th. So you don't have to worry about, going further. All right, so what comes, somebody tell me what number comes before 20?
19.5.
19. So I'm going to add that 0.5 to 19, and that is my first class boundary. Now, you could do that with each number, or you could just add 10 until you get up to 89.5. I don't care which way you do it, but I'm going to go ahead and add 10. That'll be 29.5. That comes before 30. 39.5. That comes before 40. 49.5. 59.5. 69.5. 79.5. 89.5. And I'm going to do 89.5, but I'm going to highlight it pink because some books or some test questions may have an extra blank on the last one because they're wanting it right there also. Okay, most of your class boundaries fall right here, right here, right here, right here, right here, right here, right here. But some test questions and some homework questions may have an extra blank when you type in all the class boundaries and you don't know what that extra blank is for. Well, they're wanting this one right here, which would be 89.5. Okay, so you might want to make a note about that. Sometimes some questions, some homework questions, some test questions, some standardized test questions may have an extra blank because most of the time they have blanks with commas and you type in the class boundaries. And if you have an extra blank at the end, they want in that last one, which is right there. And the class are the midpoints. I'm going to put midpoints right here because I don't have any room down here. So I'm going to put midpoints. And the first one is going to be 20 plus 29 divided by 2. And what's 20 plus 29? 49, Hubert. That's right, class. And 49 divided by 2 is what? 24.5?
Yes, sir.
And what are you going to do? Are you going to calculate each one of those, or are you going to add your class width?
Add the class width.
Yes, the smart way is to add the class width. So 24.5, 34.5, 44.5, 54.5, 64.5, 74.5, and 84.5. And that is how you get all of that good stuff whenever you're asked. And who has a question on that? Now, I kind of stuck that in the middle of what we were doing on the slides. And the reason I did that was because of the several emails that I've gotten from students who have never had probability and statistics. You're welcome. Okay. Let's get back to where we were. Oops. There we go. And I'm not going to go through this because they're just drawing a chart and then asking you to do a line chart. And I'm going to show you how to do this on your handy dandy Excel spreadsheet. I'll also show you how to do it on your calculator if you don't know. Okay. And there is something that is nice and pretty, and that's a line chart. And that's why you use line charts, because they're very easy to understand. And that's that section. Hey, we're moving along. That was 5C. Now we're going to 5E. And that is this one right here. Correlation and causality. How many of you watch the movie The Matrix? And I may have already talked about this. How many of you, somebody say, I know one person out there has seen the Matrix series.
I have to.
Okay, thank you. Miss Gill, have you seen it?
I've seen the first one. I'm
Oh,
not
well,
sure if
you don't help. No, this got to be the second one. You've got to see the second one.
Talking about the restaurant scene.
That's all right. You're a failure, Miss Gill. You're a disappointment. Just forget it.
I could do better.
I'm not going to be able to teach class today. Anyway, in the second series, which is called The Matrix, I think it's called Reloaded. They walk into a French restaurant, and that is, let's see if I can pull it up. They walk into a French restaurant, and it's Morpheus and Trinity and what's his name? Neo. And they walk into the French restaurant, and let's see if I can find it. The keymaker, Matrix 2 keymaker scene. And they walk into let's go with French restaurant scene. I don't know how to spell restaurant. Restaurant is one of those words, A-U-R-A-N-T. Well, that's right, but okay, causality, there it is. And you can watch it. I'm not gonna. There's the owner of the French restaurant, and he talks about causality, and he says, and we don't want to watch that scene with the pie, so we're not going to watch that scene. He talks about, he says to Neo, he says, I know why you're here. And he says, cause and effect. You drink too much wine, you have to pee. Now, I don't mean to, be inappropriate, but I'm quoting a quote from the movie. And he says, you drink too much wine, you have to pee. And that's cause and effect. Now, let's write that down. Well, you don't have to write down drink too much wine, you have to pee. You just have to write down cause and effect. All right? Cause and effect. I'm going to show you my document in just a minute. Cause and effect. When something causes something else, that's called causality. Causality, oh, I misspelled causality. It don't have an E in it. Okay, so I'm going to mark that out. I'll show you my page in just a second. Well, I'll go ahead and show it to you now. Cause and effect means causality. That means something causes something else. But there's another word in there that causes problems, and that's correlation. Now, can anybody that may have had probability and statistics before, can you tell me what correlation means in layman's terms? I told you what cause and effect means. That means causality, and vice versa. Causality means cause and effect. But what does correlation mean? Anybody?
A relationship between variables.
A what? I didn't hear you.
The relationship between variables.
Yeah, that could be it. You could say that. I like to get even more simple than that. I like to say a pattern. a pattern or a slope? Okay. Now I'm going to write down the most important thing that you can write down. And it's in red. Correlation does not equal causality. Causality
A work email.
equals correlation. And I might have gave y'all this example before because I can't remember teaching 4 probability and statistics classes, 3 120s and 1 103. I forget what I tell each one of you. So if I worked at a movie theater, and I'm going to use this, did I give y'all the Nicolas Cage suicide spiel? Yes or no?
I remember it, but again, I have 2 of your classes. So
Yeah,
I'm not.
you don't count. You're taking 120 and 103. 103, just 103 students. Did I tell you about the movie Suicide? Anybody remember that?
I'm pretty sure you
I don't
did.
remember that.
Yes.
I think you did, yeah.
I did? Well, I'm going to go over it again. All right. Nicolas Cage, Con Air. And I work at the movie theater and I do a study, and this is 3 weeks, the last 3 weeks of ticket sales. And I see a positive correlation right here. Yeah, I did show y'all because I remember saying that we're not going to find the correlation coefficient in this class. I remember saying that. And R is equal to 0.82, which is the correlation coefficient. And then I go to the hospital and I ask the people at the hospital, what is the suicide rate for the last 3 weeks? The same 3 weeks that I took these ticket sales. And I get something like this. And it has a correlation of 0.8. So mathematically, I can say that if you watch a Con Air movie or you watch a Nicolas Cage movie, you're going to commit suicide. And that's why you have this. Correlation does not always equal causality. Causality does equal correlation. I drink too much wine, I have to pee. All right. If this is, let's say this is wine, I can't, let's do, I'm just going to do a different color. Let's say that this green represents how much wine I drink in an hour. That's not the wrong green, it's too dark. I suck. Hold on. Let's say this green represents how much wine I drink in an hour because I don't have any room to write another graph. And over here represents how many times I got to get up and go to the restroom. In this case, does the wine cause me to make more trips to the restroom? Yes. So this correlation does equal. So is this a very important statement? Yes. Very important. You've got to keep this in your mind because on a standardized test, they may ask you a scenario type problem. And they may say, is this correlation equal causality or is it causality equal correlation? And, you know, you've got to know the difference between causality and correlation. Causality is cause. Cause and effect. I drink too much wine, I have to pee. Correlation is a pattern or a slope, like here. That's a correlation to this. But it doesn't mean that this causes this. But the green, you know, you drink too much wine, you have to go to the restroom. That is causality. And naturally, if there's causality, the correlation will follow. So hopefully that helps explain, what we're fixing to get into with causality and cause and effect. All right, so let's go back to the slide. A correlation exists between two variables. You were correct. I believe Mr. Chadman, you said that, correct? Or somebody. Who said that?
I did.
Okay, good job. Exists between two variables when higher causes blah, 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 blah. In a word, a pattern or a slope. And that's why I showed you this first. I showed you this first before I gave you the definition. Because if you put a bunch of scatter plots or a bunch of dots on a graph and you can see a pattern, then that means the correlation. The stronger the pattern you see, the stronger the correlation, whether it's positive or whether it's negative. There is a correlation between people's height and weight. That is, taller people tend to weigh more than shorter people. I agree with that. I mean, Shaq is like 7 feet tall. I mean, I don't know how tall he is, and he doesn't look like he weighs 400 pounds or 500 pounds or 300 pounds, whatever he weighs. Okay. Tall women. I think the average height for a woman is like 5'5" or 5'4" or something like that. And if a woman is 6 foot, she may weigh 150 pounds, but you can't tell it. All right. So naturally, yes, there is a correlation between height and weight. Yes. There is correlation between demand for apples and price of apples. If apples go up to $10 a pound, are you going to go buy apples a lot? Same thing with gas. What happens when the fuel, since it's going to happen again, what happens when the fuel prices go up to $5 a gallon? Do you fill up your car as much?
Nope.
No. That's when you start getting the change out of the sofa and you start getting $2 or $3 worth, to get to work or get to school or whatever. Okay? You don't fill up every time. In 2008 or 2010, I can't remember, I'll never forget when the price got up to $5 a gallon and people said that there was going to be a shortage. And I was going somewhere else. I wasn't going to get gas because I'm not one of those people that go out and panic whenever I don't believe the media half the time. And I was going somewhere else and I rode by a few gas stations and you would think that it was Armageddon. I mean, people were, and people, they do that. And you know what? We're still here and things are still going along. All right. It's not Armageddon when gas gets up to $5 a gallon. It is a pain in the butt, and it's not, to me, it's not necessary because we've got all the OIL that we need here in the United States and Alaska. But I'm not going there because I'm not going to address kickbacks that our government officials get from Ukraine and the Middle East. So I'm not going to go there. Next. There is a correlation between practice time and skill. Yes. Unless you're gifted and talented, which are outliers, the more you practice, the less you suck. And that's true with everything. It's called extra practice and hard work. I can't say it. What's it? Hard what? Work. We have some people that don't understand this one. I'm not going to say anything more. Scatter plot. I just showed you 2 scatter plots right here. Those are 2 scatter plots. You got data, you put it on a scatter plot. I'll show you how to do that with Excel, and I'll show you how to do that on the calculator. And we got to hurry because we're running out of time, and some of y'all are going to start convulsing. No correlation. There is no pattern. That usually, right horizontal line right here. No pattern, horizontal line. That makes more sense to you. Is there a correlation between how many cats I have and the color of my eyes?
No.
Well, I don't know. You know, brown-eyed people are very caring. They're very loving. So, yeah, I guess there would be a correlation if you consider that brown-eyed people are pretty much, you know, the best. No, I'm just kidding. Miss Stewart, you are correct. All right? You are correct. There is no correlation between eye color and how many pets you own. The reason I said that, I was looking at my cat. My cat was looking at me like, what the heck are you doing? Who are you talking to? He sits here and looks at me like I'm crazy when I do these classes. I'd love to know what a cat thinks. Well, no, I wouldn't, because I don't think you'd be able to say it in public. I think cats curse a lot in their mental conversations. Like, what the hell is he doing? Where dogs, they just run into walls. They don't have the capability of talking. All right, no correlation. Positive correlation, positive slope. Write down positive slope. Correlation and slope relationship. There are a relationship. Now let me go ahead and write this down for you. And this is another red thing. So you need to highlight this. Correlation and slope have the positive, negative, no relationship. Okay? If I have a correlation here, correlation goes from -1 to +1. Okay? Correlation goes from -1 to +1. I don't know how far they're going to take that with a 103, but your measurement for correlation is from -1 to +1. 0 is the same thing as slope. 0 slope means 0 correlation. Okay, so 0 slope means 0 correlation.
Does no mean no in betweens?
I'm sorry, say again.
What does the no stand for?
A horizontal line, no correlation, 0.
Oh.
In other words, if you have a horizontal line, the slope is equal to 0 and the correlation is equal to 0. That means that there is no correlation. Like how many cats I have versus my eye color. There's no correlation. A positive slope. Now, slope, the difference between slope and correlation, the only difference is that slope can be any number. Slope can go up to 155 million, but correlation goes to +1. It doesn't go past +1, and it doesn't go below -1. Slope can go to any number, but the relationship with slope and correlation is positive, negative, and none. Those three are relationships. If your slope is positive, your correlation is going to be positive. If your correlation is negative, your slope is going to be negative. If your correlation is a horizontal line, your slope is going to be a horizontal line. Okay? So I don't know if they're going to go that deep. So negative correlation, strength of correlation. All you got to write down for strength is steepness. How steep is your line, meaning slope? If you was to take the slope, the higher the slope, the more correlation you have. So no correlation, horizontal line. Positive correlation, positive slope. Negative correlation, negative slope. Strength of correlation, steepness. How steep a line is, a correlation line is. Or the pattern, whatever you want to call it. And we need to shut down at 10 o'clock, I know that. So here, if I was to draw a line right here, it would be right through here. And that would be a positive correlation. Now I'm going to show you how to do this on your Excel spreadsheet and your calculator. I'm going to show you how to do it. But I don't know, we're going to get into that later, I think, in 103. I don't know if we're going to get into that now. All right, a scatter diagram shows, yeah. There's the line right there. And after you do some problems with me, you'll see, you know, how to do that. Here is a negative slope, negative correlation. Now, that's what I will ask you on a standardized test. I mean, that's what you'll be asked on a standardized test. And I do put a couple of these on your test. And you should be able to tell a positive correlation and a negative correlation. Just try to draw a line that, you know, best fits in here. It'd be somewhere through here. You don't have to write this down. I mean, you can just draw two graphs and put some dots on it and have one go positive and one go negative. But I think they're going to give you that slide here in just a second. But they do have a good example in the book. There they are right there. Positive and negative. Okay, I don't know where we are. Somebody write down, we are on slide 9, and this is 5E. We're on slide 9, and we only got, you know, we're on about halfway. So slide 9, somebody put slide 9, please. And I will shut her down. And y'all are welcome to ask questions or hang around. The rest of you can make like a bat out of hell the way y'all do, or you can leave, you know, however you want to. And I will see y'all when? Friday. See ya.